Let's take a look at question 8. Question 8, we have a differentiation question and also Maclaurin series. So what we're gonna do here for question 8, they want us to differentiate y 4 times. Notice that we have cos x multiplied by sin x. That means we have to use product rule. Let's begin. Okay, so first let's list out. If I have cos x and I want to differentiate, this one will become negative sin x. Next, if I have sin x, if I differentiate, I will get cos x. If I have cos x, differentiate, that will be sin x. Next, if I have sin x, differentiate, that would be cos x. So what I'm doing, this is my original and this is after differentiation. So we will be using this color. When we copy the same expression, it will be in purple, but if we differentiate, it will be in blue. So let's begin from the beginning. So y is equal to cos x sin x. So dy dx is equal to, let's start by differentiating cos x. We will get negative sin x. And then copy sin x plus copy cos x. Next, we will differentiate sin x, which is cos x. Simplify this equation, so we will get negative sin x plus cos x cos x. We will do the second differentiation now. Okay, let's begin by differentiating negative sign. So that would be negative cos x, copy sin x, copy negative sin x, and then differentiate sin x, become cos x. Next, we will differentiate cos x, which is negative sin x, copying, because this is differentiation. Okay, so I have to use blue. So differentiation of cos, that would be negative sin x, and then copying cos x. Okay, and then copying cos x and differentiating cos x. Let's simplify. So this would be negative cos x sin x minus sin x cos x minus sin x cos x plus cos x sin x. These two will eliminate each other. That means our final answer for the second differentiation would be negative 2 sin x cos x. Okay, time to do the third differentiation. We'll begin by differentiating negative 2 sin x. That would be negative 2 cos x. Copy cos, and then plus copy negative 2 sin x, and differentiate cos x, become sin x. So our simplification would be negative 2 cos x minus 2 sin x sin x. Moving on to the fourth differentiation. We'll begin by differentiating negative 2 cos. So that will be positive 2 sin x. Copying cos x and then copying negative 2 cos x And differentiating cos x become sin x. Now we will now differentiate negative 2 sin x. So that will become negative 2 cos x. Copy sin x plus copy negative 2 sin x. And then differentiate sin x will become cos x. Let's simplify this equation. So this would be 2 sin x cos x minus 2 cos x sin x minus 2 cos x sin x minus 2 sin x cos x. This and this will eliminate each other, so we will have negative 4 cos x sin x. And what is cos x sin x? Cos x sin x is equals to y. So our answer is the fourth differentiation is equal to negative 4y. That's it. We are done with part A. Moving on to part B now. Okay, we want to find the first 3 non-zero terms for the Maclaurin series. What is Maclaurin series? Okay, we will be using this formula that is given in your formula booklet. So before we plug in all of this, what we have to do, so let's ease our computation. So what I will do is writing down the value when x is 0 for all 4 trigo. So sin 0 is 0, cos 0 is 0, cos 0 is 1, sin 0 is e to the power of 0 minus e to the power of 0 over 2, which is equal to 0. And then cos 0 is equal to e to the power of 0 plus e to the power of 0 over 2, which is 1 plus 1, 2. 2 over 2 is equal to 1. That's it. Let's start plug this in into our y dy dx until the fourth differentiation. Okay. The first y is equal to cos 0 sin 0, which is equal to 1 multiplied by 0, 0. dy dx is equal to, okay, negative sin 0 sin 0 plus cos 0 cos 0. So what I have is negative 0 multiplied by 0 plus 1 multiplied by 1, which is equal to 1. Moving on to the second differentiation. Second differentiation is equal to negative 2 sin 0 cos 0. So this is equal to negative 2 multiplied by 0 multiplied by 1, which is equal to 0. The third differentiation. So d3y dx cubed equal to negative 2 cos 0 cos 0 minus 2 sin 0 sin 0. So we will have negative 2 times 1 minus 0, which is equal to negative 2. Okay, let me bring this slightly here. Okay. Okay, so the fourth one would be d4y dx power of 4 equal to negative 4 y And what is our y? Our y is 0. So negative 4 multiplied by 0 is equal to 0. They want us to find 3 non-zero. So we already have 1 and 2. So we need another one. So what we have to do is we have to differentiate again. So let's differentiate this. So d5y dx power of 5 is equal to negative 4. Differentiate y would be dy dx. So negative 4 multiplied by, what is our dy dx? Our dy dx is 1. So it will be equals to negative 4. So now we have 3 non-zeros value. Let's plug that into our Maclaurin. Okay. So Maclaurin is equal to, y is equal to, okay, 0 plus x multiplied by 1 plus x squared over 2 factorial multiplied by 0 plus x cubed over 3 factorial. We're looking at the third one now. Okay. Negative 2 plus x to the power of 4 over 4 factorial multiplied by 0 plus x to the power of 5 over 5 factorial multiplied by negative 4. In order to make this, okay, working is more continuous, I'm gonna move it down here. So this would be equal to, y is equal to, okay, here would be 0, here would be x minus, okay, so 2 over 3 factorial. Okay, so that would be 1 over 3x cubed. That will be another 0. So now we have, okay, negative 4 over 5 factorial. So 4 over 5 factorial. So that is negative 1 over 30 x to the power of 5. With that, we are done with part B as well. Okay, so let's just mark. This is the answer for part B. Okay, and this is the answer for part A. Let me just make this slightly bigger. So that's it.